Hello friends, I'm going to explain how to enter the elemental composition in the online platform Py-MLBUF. We need the elemental composition. So for that there is a table. For example, there are 8 elements and their compositions in this table from serial number 1 to 8, followed by the chemical symbol of the material. Next column explains about the type of material and its density. For example, pure element, single compound, multi-elemental material, and multi-compounds materials, corresponding their densities, in gram per centimeter cube. And the next column, their chemical symbols have been mentioned. The right side of the table describes that how to enter this information in the online platform. There are 2 methods to enter the input. That is either by atomicity or by weight fraction. So, for pure elements, we provide both the methods to enter that input composition, but in case of multi-elemental materials, sometimes only one type of chemical composition is available. This table explains all about the input procedure of the online platform Py-MLBUF. Now, we are going to do it practically, with examples. We will enter the data for aluminum, oleic acid, and silicate glass. This is the interface of the online platform, Py-MLBUF. When it opens, this type of interface appears on your screen. Enter a number of layers in your shielding enclosure. That is, if you have a single layer shield, then enter 1, and for double layered shield, enter 2, and so on. I enter 1 as aluminum is a single layer shield. Now, it asks next question, that is about sample's composition type. Elemental or compound. I enter the elemental composition, then click on submit, and go further. There are 3 energy ranges appear on the screen. The first, energy range, from 0.1 to 15 MeV, the second, from 0.015 to 15 MeV, and the third, is the custom energy option. It allows the user to enter any number of energies, from 0.015 to 15 MeV. Then, the portal wants to know about the plotting of graphs. If you want to plot the graphs, then select yes, else no, from the available options. Now, enter the density of the sample. As we have selected aluminum, and for aluminum the density is 2.7 gram per centimeter cube. So, enter 2.7, and then enter its symbol, that is Al. For the first time, you have to enter symbols. After that, it will show automatically in the drop-down window. As I have already tried it with aluminum, that's why it shows in the drop-down list. Then, enter the atomicity, or weight fraction, of the chemical composition. Because we have selected the atomicity. So, enter symbol Al, followed by 1, that is, its atomicity. And click on submit. After that, it starts calculating the gamma ray shielding parameters, that is GSP data, and starts plotting of graphs. Thereafter, it compresses the generated data into a zip file, comprises of the results, and send it in the email to the user. See that the email has been received. Click on download, then open it. You can extract it or open directly from here. This type of data provided in the result file. You will get plots at particular optical thickness. It provides the energy exposure buildup factor and energy absorption buildup factor from 0.5 to 40 MFP at 31 energies. As this platform has been designed particularly or specifically for the calculation of buildup factors. So, it will provide the calculated buildup factors for all energies in a tabular form for the sample. It also provides the calculated values for gamma ray shielding factor, GSF, that decides the shielding efficacy of an enclosure. The K parameters data is also there, which decides the behavior of the photon in the sample thickness. The K parameter represents the gamma ray dose multiplication with thickness and change in the shape of the spectrum from 1 MFP. This is a unique online platform which provides such types of useful shielding calculations for buildup factors of single-layer, multi-layered enclosures, and their many gamma ray shielding parameters. Thanks for your patience in watching this video tutorial. For more tutorials, please explore the help section of Py-MLBUF.